Hallo tuturor, spuneți-mi vă rog dacă mă auziți. Bun, să vedem cam cât suntem. Nu prea mulți deocamdată. Mai stăm un minut, două și apoi începem. All right, I have to go in English. Forget about that again. Right, while you guys are gathering up, I'll get some of my things here set up. Alright. 13, let's wait till 20 and then we get going. 'Alright guys, let's get going. So today we will go through a few examples of thread programming that will try to touch every single synchronization mechanism that we have discussed, except for the barrier. I don't think we'll have that one, but we'll have all the others. And for that, I will have to tell you the scenario that we're trying to implement, and I will also need some, let's say, utility functions that will tell me the time that has elapsed since the beginning of the program, and then a function that just idles for, let's say, 100 milliseconds, and the start function that just registers the start time of the program. And since I will need this in several programs, I figured I would show you how to do this in a separate file. I created the header file in which I include time.h because I need the structure start time from there. I declare the headers of my functions, and then I have a common.c, right? This is common.h. Then in common.c, I include common.h and I provide the implementation for these functions. And then I will simply include common.h in my main. And when I compile, I provide both the main function file and common.c. You'll see how this is gonna happen. For now, let's just stay as such for now. And I will just start the first version of the program. And I'll call it V because we're going to simulate a voting scenario, right? So let's suppose we have a number of candidates And voting for a candidate means incrementing its position in an array. The people who will be voting will be threads. So we'll be creating a lots of threads. The threads will generate the ID of the candidate that they want, and then they will plus plus that candidate's votes, and that's it. We'll start like this, and then we'll move on. So let's start uh, writing this. So I'll need stdio.io.h, and I will need pthread here. I'll start without any synchronization, then we'll discuss how we synchronize, and then we'll keep adding requirements on this problem till we are happy with it. So let's have two macros. H from humans, this is how many humans will be voting. So let's say, or maybe, yeah, H, it's good. Let's say we'll have 10,000 humans voting. And this means we'll have 10,000 threads, right? A thread will be a person. And then, thank you. We will make a mutex for each candidate. So let's for now, but I need to write the code, so it will take a while to get there. Just bear with me. So let's say we'll have n candidates, for now 10 of them. And votes is where we will vote. All right. So for now, let's have the voting function, or the voter, sorry, this is the voter. And what will a voter do? A voter will do something like this. K equals a rand. This is actually for rand, I will need to include stdlib. We'll include a random number modulo n, and then all it has to do is vote of k plus plus. This is voting, nothing more to it. Well, there will be a lot more to it, but for now, this is how we go about it. And no synchronization till we see this, discuss a little bit how it works, and then we'll go the way Radashika suggested, with one mutex per vote, but still, sorry, per candidate, but we'll still need to figure out why that and not something else. So now this is going to be the usual thing. We have to create the voters, which means a bunch of threads. Let's call them H because they are humans, apparently. And I'll need an int to cycle here. So for I from 0, I less than H, I plus plus. And I'll need this again for joining. So pthread create. This is the handler of the thread. No attributes. Function is voter, no arguments. Right. So we created the thread, and now we join the thread. Right, so this is very simple code that creates 10,000 threads, and then they just add to the votes. One more thing that we have to do is to initialize the votes to 0, since this is C and it doesn't really do much for us. So votes of I equals 0. All right, so this should be quite straightforward for you, and let me just compile this to make sure it's all right. So this is going to be v1 because we'll have several versions of this voting, and we compile v1.c and common.c, right? So this seems to be quite clean. What I would like to do now is to try to prove that if we leave it like this, the votes will be actually corrupt, meaning after everybody votes, we'll have less than 10,000 votes. In reality, I don't think I'll be able to do that because I'm not able to create a large enough crowd to have n plus pluses, I mean plus pluses overlap. But nevertheless, let's display the total of votes. In the previous class with the Romanian section, I wasn't able to get this to go bad, which actually is a lesson in itself. You should start getting this, that although the program runs fine, it doesn't mean that it will always run fine. It doesn't mean it doesn't have uh, concurrency problems. So in this case, although when I run it, it prints out 10,000 votes, and I can run it a number of times, it will be the same thing. That does not mean that I don't have a problem here. It's just that I'm not creating enough of a crowd so that the probability of plus pluses interleaving occurs, and then things go south. Yeah, well, let's try. Let's see. Let's see. Maybe. Let's put just two. But the thing is, nah, it's hard. The thing is, you need to understand it runs okay does not mean that it's okay. You have to use your logic and look at it and make sure things are properly handled. So now, if we want to make this correct so that it will survive in, all sorts of abuse, if you run this on a very, let's say, busy system, then it will go bad because threads will be interrupted and other threads will kick in, and then you have a better chance of things going bad. But on this machine, I only have a few processes, so we don't see that. So let's stay with 10 candidates. So what options do we have for synchronizing access to the votes? The simplest one would be to have a mutex, just one. Lock the whole thing, vote, unlock the whole thing. Now, this is not necessary. It's a little too restrictive, or quite too restrictive. Even in real life, if you were to translate this, would be, well, at my voting, and actually, I don't know how you call it in English. I'm not sure it's a voting section. I don't know. It's, a second, please. It's a voting, let's call it section. Maybe it's not the right way, right? So it would mean that in the voting section, only one votes at a time, which is not really necessary. A booth? Well, no, because the booth is the little thing. I'm talking here about the room into which you go, you show your ID, and then you're given the stamp and all that, right? So it's not the booth. The booth is where you're alone. This is more like the building, voting center. Let's call it the voting center, right? So if we use only one mutex, that means that in the whole voting center, only one person votes at a time. Not realistic. And we don't need to be so restrictive. We can have multiple mutexes, one per candidate, and each voter will just lock that candidate, plus it, and unlock it. So then we will have more concurrency and better performance. Using just one mutex would be still correct. Data will not be corrupted, but it's too restrictive. So let's go with the other way of having one mutex per candidate. So here we go. Mutex, and now we need to initialize them, and I think I'll stick the initialization right here. Right, we initialize. and then the destruction will be in this other 4. I'm just going to reuse it. All right. So with this, all we need to do is to say pthread mutex lock, and unlock. So in this way, the code is correct. I know that the votes will not be corrupted. Every voter will have a lock on the votes of the candidate, will plus it, and then will be fine. But actually, this is not I, this is going to be K. Sorry about that. Copy paste again. Oops. Right? So let's see if there are questions up to this point regarding why it's better to just have one mutex per candidate instead of one for everybody, or anything else in this implementation. If there are questions, please type them in. I guess this is simple enough, so nobody has questions. So I would like to introduce a second uh, restriction that would model a real voting center. Let's put this in V2. So the restriction goes like this. A voting center normally opens at a certain time. So I would like my voting to open at a certain time. Right now, everybody just goes into the voting center and votes. And I would like to say, you know what? Opening time is 5 seconds after the program started. So until that time, nobody gets to vote. After that, they can vote in any way they want. So how would I implement this restriction? How would I prevent threads from being created? Sorry, from getting into the voting before it's open. And I would like suggestions from you. What mechanisms could I use? How? And so on. Okay, so we have Mr. Steff saying with the barrier, and we have Radashika saying we can make a thread that waits 5 seconds, and after that sets a variable to true, then all other threads wait for that variable. Then we have Berzan saying sleep when the program starts for 5 seconds. And then we have Radashika saying we could use a read-write lock to achieve that. Conditional variable signaling after 5 seconds, it says water addict. All right, so we have a bunch of proposals here. So I'll take them one by one. Barrier. Barrier is not exactly meant for this. Barrier is mostly like a point where all threads gathered and then they move on together. Now, if I were to use a barrier, I would say nobody votes until everybody arrives at the voting center, which is not exactly what I need, right? I need threads that pop in after the opening time to go in, but those who come before the opening time to wait. Barrier says everybody waits until everybody's here, so not exactly good for modeling this. Although what I'm requiring is tempting, it kind of looks like a barrier. Next one is have a thread to sleep for 5 seconds and then put a variable, a flag on true, and then all these other threads go on. So this solution would work, but it would require mutexes to protect that variable or make that variable volatile. So I will leave this to you to read because volatile is a rather sensitive thing that differs from programming language to programming language. And it's, let's say, in a way, build your own. But we do have mechanisms that support this. So I would rather not go with a crafty solution. Rather, I would go with something that uses the tools that we have already. Now, Berzent is actually um, using Occam's razor and says, you know what, if you want to start only 5 seconds after the program starts, just sleep 5 seconds. Thank you. It's what you're saying is very correct, but I would rather, create the threads right at the beginning because basically here I'm creating the people, right? And then I would like to these people to wait until they vote. So what you're saying is put the whole damn creation on hold for 5 seconds, then start creating people, then send them to vote, and that will respect your requirement, which is good. Okay, hold on. He says no. I meant to use. Oh, now I'm confused. So how would you use the read write lock? The voters would spin in read locks. We could have a mutex oh, you're thinking to lock all the mutexes and then after 5 seconds let them go. Mortuary, that would be a solution, absolutely. You can do that as well. Let's see what Rishika says. I'm confused because you're mentioning read write locks and then you're mentioning a thread that sleeps. I don't know because you seem to kind of go towards conditional variable, which is where I want to go. Although mortuary solution is just as good, I would like to make use of a conditional variable, meaning this guys here would sit in a wait on a conditional variable if the time has not elapsed, and then somebody would need to wake them up. Who would be able to wake them up? Probably the maid, right? So this I'm going to take this route, although there were other solutions which were correct, some of them less elegant, some of them more elegant. But I would like to take this route so that we play with conditional variables as well. So let's, if we have a conditional variable, we'll need a mutex as well. So let's have a mutex, which will be, let's say, open mutex, right? And then we'll have a conditional variable. Using the conditional variable will help versus the read-write lock suggested by Rishika because in his case, the threads will spin. I guess that's what I understand of his solution. Threads will spin, checking if it's time already. But in my approach with conditional variables, the voters will just sit and wait to be told the section is, the voting center is open. So this would be an open C, let's say. Okay, now we need to initialize these things. And we need to destroy them somewhere down here at the end. All right. So now how do we use them? Well, these guys will have to wait, but they can choose their candidate before the voting center is open, right? So we leave the k equal rand as it is, and here we will check if it's open. So what we're gonna say is this pthread. So don't forget we need to log the mutex. Pthread mutex lock of openm, and then we well, actually, let's write that later. And then while, and I'm going to use that function from the common file, elapsed less than 5, pthread cond wait open C open. And once the time has passed, all it has to do is unlock the mutex and then move on to voting. All right, so this would be how you wait for the voting center to open. Now, who should wake these guys up and where? I'm thinking to have that happen right here after the threads are created. And I would just have to have a broadcast on the conditional variable, but main will have to figure out that 5 seconds have passed. So it will be something like this, so this guy will spin. While elapsed is less than 5, let's just idle for a little bit, right? Idle just sleeps 100 milliseconds. It's a little implementation I made. So basically now, when the program starts, we create the voters, and then we stay for until 5 seconds have passed. Oh, by the way, I have to call here start. Start being record the start time. It's another of those little functions that I implemented. So we wait here till 5 seconds have passed, and then we broadcast the OpenC conditional variables, and all those guys who are waiting will go in and vote. So I would like to hear questions about this implementation right now. Actually, not here, but read. In the meanwhile, I will compile it, and I will also have the threads print a dot so that we see that they stay, and after 5 seconds they get going. 1 second, I'll get to your question. Let me just run it first. Yeah, V2 this time. All right, and now we have a bunch of errors. So I have a lot of p threads instead of p threads. Let me fix those. Let's see what else have I got going wrong here. Elapsed. You don't know who elapsed is. Oh, I forgot to include common.h. Let's include common.h. That's my little header. Okay, so now it compiles. I'll put the code up. Actually, I'll even run it, and then I'll answer questions. So we wait for 5 seconds, then the voting center opens, and we should see, you see the dots are the voting, and then in the end we announce 10,000 votes. All right, so let me see what has been going on here. Oh, guys, you just wrote a lot. All right, so this was it. I don't understand why does the voter has a while elapsed and doesn't the main set the conditional variable to true? All right, it's a good question. I'm kind of sticking to a standard way of using conditional variables for the sake of it. Okay. It's unlikely that this will be awakened before. So this could actually not need a while at all. We could in fact just do this. But if this condition could go back and forth due to external factors, meaning that when you were awakened it was true, but when you actually get out of wait it's not true anymore, then we would need the while. But in this case, as you know, the time doesn't go back, unfortunately, we don't need that while at all. I agree with that. Uh, Now let's see the other part of it. Why doesn't the main set the conditional variable? Well, the conditional variable cannot be set to true. It can only be signaled or broadcasted. So there is a confusion there. Then we just need to wait for the conditional variable to be set. I'm again confused about the setting to true. The trick here is that you wait at the conditional variable and another thread signals you and you wake up. If you want to wake everybody up, then you broadcast. Because the thread may start after 5 seconds. Yes, you may have not, it's unlikely here, but if we have loads and loads of threads, you may have threads created here after the 5 seconds have passed. We can actually make this quite slow if if we need to. All right, let's see the debate. And they won't have to wait for a broadcast. Yes, yeah, but the conditional variable is set to true. Where is it set to true? Can you clarify that? Okay, what I meant was that we don't need. Yeah, I agree with that. I agree that. However, again, I I chose to put the while because sometimes, I mean, this is a condition that once has reached that is once it's true, it's never gonna go back to being false. But some conditions will vary, will be true and false back and forth. This one, once it gets to be true, it doesn't go back. So then I don't need to check it here. When I'm awakened, it will be guaranteed to be true. Oh, okay. So setting it to true, you mean signaling. Yeah, so I think we were in agreement here. And I actually removed that from there. All right, so are there other questions about this piece of code? I'll run it again. All right. Anybody else has questions about this? All right. So we have the threads, they vote. Well, here is something interesting. I didn't get to have this happen before. Let's just have a look. You see, it seems to be stuck. Let's investigate this a little bit. What's going on here? Well, this is a use case that I didn't think I could create, but the program is stuck. How could it be stuck? Exactly. Exactly. Thank you. So removing that while was a really bad idea. I should put an if at least, because otherwise, if a thread starts after 5 seconds, it gets stuck. I'll get to the broadcast locking. Thank you for that. I'll get to it. Uh, all right. So I think we have our answer for the program locking up. Now it shouldn't happen again. Let's just have a look. The fact that it doesn't happen during this run doesn't mean it won't happen ever, but at least we see it going to the end. Okay, so you guys are having trouble. I'm not sure how to fix this. Uh, I'll just wait for a few seconds. All right, it blocks a lot. I'm sorry about it, but I don't think I can fix anything about it. And I just hope to God my network doesn't go down. Because then I don't know. Might be mine. I don't know. Although we don't have a lot of transfer going on here. But who knows? Maybe somebody in in the building is downloading now. Everybody starts Netflix right just about now. Had lunch, see a movie. All right, so I'll just go on. I'm sorry that if it buffers, I'll have to push on. So there was a question. There was a question about let's see, somewhere up there. Somebody said, yeah, Parvanescu, why do we log the broadcasting? Uh, why do we log the broadcasting? Well, you don't really need to, although I would rather have you do it because you need the mutex here. I would rather have you log the broadcasting to. In C, they don't really force you to do it, but in other languages, they do. And because these conditional variables are meant to be used in conjunction with a condition that can change values, you will need here to lock and protect that condition before you broadcast. So that's why I'm locking the broadcast. Any other questions on this matter, please? I will just add another requirement, but I just want to make sure we're fine with the conditional variables. And it looks like we are. All right then. So let's move on to the next requirement. You know, it being a pandemic and whatnot, you don't want to have too many voters in the voting center, right? So then, how would we limit the number of voters in the voting center? In other words, we should limit the number of people doing this. What mechanisms do we have and how can we use them to limit the number of people voting at any one time? Semaphore it is. What will determine the maximum number of voters that can go in? All right, semaphore again, but something about the semaphore will determine the number of people that can go into the voting center, and we'll need to figure out how to do that. So you guys think about it and let me know when you figured it out. I'll get from my perspective, for a few minutes, everybody says semaphore every now and then. But what I'm asking is, how do I configure the semaphore so that only a fixed number of people can go in at any one time? In the meanwhile, I'll declare my semaphore here. I'll initialize it. Now, semaphore is a little different, meaning that it doesn't really an arbitrary number, but what I'm looking for is for you guys to tell me that you initialize the semaphore. Yes, thank you. You initialize the semaphore with a value, and that initial value is the maximum number of people that will go through it. So let's say we only allow 3 people in the voting section at a time. All right, so seminit with an initial value of 3, this one, will mean that only 3 people can go, only 3 voters enter the voting center. This 0 marks whether or not, you see, shared, whether or not our semaphore is shared across processes, but it's not. It's only threads, so we'll put it to 0. So we initialize the semaphore. Now, let's destroy it as well. I'm not sure I mentioned, although I remember doing. Semaphore is the one that doesn't really respect the whole pthread something name of the functions. It has shorter variants of its own. There is a huge delay between your stream and what we see. It's hard to answer. Oh, I'm sorry about that. Okay, so Mortuary, when you say low latency active, is that something I could configure, or is it about you guys? I'll wait a few. Okay, it's for you. All right, so guys, just do what Berzent says, or Mortuary says, or whoever says something. Okay, all right, so let's move on. We initialize the semaphore with 3. We destroy it at the end. Now we're using it. So where should I wait for the semaphore Basically here. It makes no sense to wait for the semaphore. Yeah, waiting for the semaphore here would mean uh, only 3 people can wait for the center to open, but that's not realistic. All I need is before you enter the center, you need to make sure there is only 3 inside. So sem wait on the semaphore, and when we're done, sem post. Okay? Now, running this won't really show much at this point. Well, except for errors. But that's not running it, that's compiling it. Social distancing, I don't know how to do this social distancing between threads. Maybe if I just pull the CPUs apart a little bit on the main board, but then I need a new laptop. So that's problematic. So okay, so running this won't really show much. But what I want you to get is the idea of how I'm thinking about these things and how I model them. Running it, you don't get to see a lot. All right, so headshot spy, you don't understand why it doesn't work without this. So I'll take a look, I make a parenthesis away from the semaphores. If I have a thread, a voter, that is created after 5 seconds have passed, that voter will, and I don't have this if, that voter will enter the waiting. But there will be nobody to wake him up because the waking up has been done already, right? And then it will be stuck here. Indeed, I create all the threads. So let me try to squeeze this in so that it fits all on the screen. Just give me a second. Oh no, I'm good. I just need one line to collapse and I'll see everything. So although I'm creating all the threads here, so all the voters are created here, and then I broadcast, okay? It is possible that some of these voters will actually not get processor. There are 10,000 of them. So they will not get processor to even do this. Then 5 seconds pass. This guy maybe gets processor, wakes everybody up. Whoever is waiting. Of the 10,000 threads, some of them will not have reached this. By the time they reach it, 5 seconds have passed. Those who were waiting were woken up. And if I don't have this if, that thread will just jump into waiting, but nobody's going to wake it up. So I need to make sure they're not going into waiting unless they have to. Because if they do, there is nobody to wake them up. So headshot spy, is this better? Oh, all threads are created equal, but some of them are luckier than others. So it's luck. It's not being, favored by the system. All created equal, but some of them get CPU before others. Net, yeah, like in real life, more or less, indeed. So let's see if there are other things to be discussed here. Right. Uh, you notice that now we have a critical section that is protected now by two synchronization mechanisms. First, you reserve a space in the voting center, then you lock your candidate, then you plus plus, then you unlock your candidate, then you release your place in the voting center. So this is something that every now and then you will need to do. You just need to think it and figure out how to do it properly. So let's see. We've figured out how to vote and not corrupt the votes. We figure out how to start voting only after the center opens. We figure out how to not have too much of a crowd in the voting center using semaphores. Are there questions on this in Okay, we have a question, but if there are others, please just type them. However, in practice, should we consider exceptional cases like this? The optimal number of threads is really um no, this is not a well, I wouldn't know what to tell you. In some cases you may I don't know when, but you may get better performance using 10,000 threads, but very rarely. Or you have a lot of processors. All right. But if you have, let's say, if your work, so I'll make another parenthesis here. If the program is CPU bound, meaning that all it does is calculations and very little disk interaction or socket interaction, then a number of threads equal to the number of cores would be the best you get. You can have more, but you're not going to see any improvement in performance. However, if you do work with the disk and with the network, then the number of threads that can help can be much larger. Can it reach 10,000? Maybe it can. Meaning, can 10,000 threads do better? Maybe so. But it really depends on your resources, meaning hardware. Okay. Uh, so yeah, I haven't really needed any at all to create 10,000 threads to perform a calculation. But this is, let's say, an artificial example meant to show you how to reason things and come up with solutions. Well, even if you create a lot of threads for asynchronous means, you're not going to create 10,000 just like that. Because well, maybe I need to make another parenthesis. These are threads, these are system threads. When you do async work or you look at these lightweight threads, maybe user level threads, maybe what do they call them? Fibers. Maybe if you go to the Go programming language, Go routines, yeah, those you can have thousands upon thousands because they are not really system threads. They're on top of system threads. In the user level, they're really cheap, so you can have them by the truckload. But system threads like this, 10,000 rarely gets justified. All right, other questions on this? Right, apparently not. I just want to say another thing about async. Async programming will actually rely on a more or less fixed number of threads called the thread pool. So whatever you do async, it will be assigned to one of those threads. So it will be a limited amount of threads, not thousands. You may have thousands of async pieces of code that need to be executed, but they will be actually executed on top of just a few threads. Sometimes just one, if you look at Node.js. All right, so let's go to the next requirement, next restriction. What if I want to get partial results, right? Not, but this will be kind of illegal, not exit polls, but rather I want to look at the votes, sometimes in the middle, right? To see how we're doing. What mechanisms could I use to get this happening? Partial results, just report the number of votes some at the point before they're done. I will wait for your suggestions, hoping that the network works fine. Barriers. How would you use a barrier to get a partial result? The read-write lock too, but we need some threads that also read the partial results. All right, let's see if there are other opinions. I'm a little intrigued by WaterAddict's suggestion for barrier, because I don't see how I would use it. Partial result would be somebody who just looks at the results. It doesn't change them, just looks at them. So barrier, unless you elaborate on it, I'm not sure I can do much with them. However, I can think of the read-write lock suggestion. Oh, no, William. I don't want to stop the voting. I don't want to interrupt the voting just to. I don't want to stop everybody just so that I get a partial result. I think I get it now. I kind of think I get what WaterAddict wants with the barrier. Maybe if we have 10,000, let's see, because he's explaining. Right. So I think that, yeah, I figured this is what you wanted. So he's thinking, let's have a barrier for 5,000 threads, and then look at the results, and then let them move on to the next, the next 5,000. But I don't want to stop the voting. I just want to take a peek and see what's there. All right. Uh, I guess William, aka Death, with the conditional variables, is thinking of the same thing as WaterAddict. Although barrier it's still unclear how would actually stop the voting, because barrier doesn't stop anything. Barrier just waits for people to gather. So maybe conditional variables would be what we use to say, okay, we had 10,000 votes, now let's wait so that somebody counts the votes, and then we move on. But that's not what I want. I want something illegal. I would just want to look at the votes while people are voting. Okay? So this kind of suggests a read-write lock, but pay attention here. Probably Berzent, when he suggested the read-write lock, thought about the natural thing, voters write, and the partial results just require reading. So that would suggest, yeah, let's have the voters write lock, and let's have the partial result read lock, which is perfectly fine. The question is, will it give any performance improvement? And here I just want to ask, when are read-write locks actually useful? Oh, no, I'll just have the main count the votes, maybe. Doesn't matter, just somebody counts the votes. I don't need to have many threads counting the votes. But when are read-write locks useful? Yes, when you have a lot of reads. But in this case, you don't. In this case, you have a lot of writes, and you'd have a few reads, very few. So read-write lock is a tempting go-to solution, but it's not really necessary. It's not going to bring us any benefit. So if we wanted to get some partial results, we could simply just look at them and use the mutexes that are already in use for voting. You just log the mutex for a candidate, you take its votes, report them, and then you release the mutex. Yeah, we can just really. I mean, I'm not saying you cannot use write locks. You can use read write locks. It's just that they are not gonna give you much. Can the voters see the partial results? I mean, the voters just go and vote for their own. If you want the voters to see the I'm not sure. The partial results for me was something that I just print on the screen, so it's not something with the thread that can consult. Yeah, I use spies. This is totally illegal, but it's also fake, so who cares? Thank you, Radoshika. That's a very good point, and I was getting to it. So if you want absolute accuracy of the partial results, then you would need to wonder what exactly is this accuracy. Uh, if you want to have a frozen moment in time reported as partial results, then you would need to lock the whole voting count and then move on with the voting. But partial results, as Radhishika says, they're not really something that need to be that accurate. You just need to get an idea about what's there. And as long as you only look at it, you might even skip locking. All right? The risk would be that you read a partially written int, which I don't think it's possible. So you could even skip locking. But this is specific to this case because partial results don't need to be that accurate. So just forget it. I would still make them volatile, the voting counters, just so that but I I should be fine without any kind of synchronization. So when Mortuary says we must not overcomplicate ourselves, I agree. But if we try to avoid complexity, we need to know why. In this case, avoiding locking things is justified by the fact that partial results don't need to be that accurate. A number that I read while it's being written is not going to make that much of a difference because it's a partial result. But if accuracy was crucial, then I should give up. I could not give up locking. I would have to use locking. Are there other questions on this matter? All right then. So then let's just move to the last example for today. I'm gonna leave this voting metaphor behind now. I'm just gonna go to a little problem that will cause trouble, and I want you to see it and figure out how to fix it. Um, so I think we kind of touched all the synchronization mechanisms, save for barriers. Let's go now to something that I will call maybe 2.c. Doesn't really matter why. So the problem that I'm going to do is this. I'll have an array of integers and a bunch of threads. And each thread will choose two indexes and swap their values. And it will do this a number of times. And that's it. Right? So let's just get going.